the Code Explain AI system developed for Nvidia. Large-scale software projects often involve distributed teams with limited direct interaction, making code comprehension challenging. Our team of 6 tackled this by splitting into front-end and back-end roles, initially 4 on front-end and 2 on back-end. We managed collaboration through clear function definitions and GitHub issues. After building the core functionality, we rotated between issues based on availability. And the result? A VS Code extension that uses static analysis to trace dependencies and an LLM-powered system to explain them.
Our solution comes in the form of a VS Code extension, comprising 2 main parts, the comprehensive analysis and the AI system. The analysis forms the core of our project and is designed to handle most general uses of our tool by providing detailed and insightful information on the selected function, including a clear summary of its purpose, precise typing information, and its dependency variables and functions. Complementing this, the AI chat assistant is specifically crafted to handle complex and conventional edge case requests, utilizing the advanced capability of Gemini to effectively answer questions within a broader context of the code base.
When designing and implementing the user interface, our key design objective was seamless integration into the user's existing workflow, as we know how important that is to our user demographic, developers. To achieve this, throughout the extension, we use font styles, sizes, colors, and code styles dynamically adapted from the user's VS Code preferences, in addition to ensuring that code and natural language responses are distinct. For front-end back-end integration, we've opted for a streaming approach utilizing an asynchronous receiver. Rather than making our users wait for a complete response, our implementation progressively renders results. Through this, we have a responsive user experience despite the inherent latency involved in LLM-based processing.
Our project allows you to use Control 7, or any other keybind of your choosing, to perform an analysis of a function, which will open our front-end UI panel and pass the current file and line of where your cursor is placed, which should correspond to the function you want to perform the analysis on, to the backend, which fetches the actual code and data we use to perform the request. We then use currently opened files, up to a limit, as context and query an LLM API, currently Gemini Flash, to generate our function and perform our dependency analysis. We then take this output and render it as if it were Markdown. Afterwards, we can move to our Code Explain panel and press Enter, which will allow us to chat further with the LLM about our function, asking additional questions that might not have been answered and gaining further insight.
So when you open the panel, 3 key processes happen. First, we check for function existence by using VS Code's symbol provider to detect the function at your cursor position. The program scans the document for function symbols and determines if a valid function exists where you click. Second, our dependency extraction process identifies all variables, functions, and classes used within that function by analyzing each line of code, finding word boundaries, and using VS Code's definition provider to track where each identifier is identified. Finally, these dependencies are filtered and fed to the LLM API, specifically Google's Gemini model. The LLM then generates concise, targeted explanation for both the main function and its dependencies, which is sent back to the panel for display.
Our Code Explain extension occupies 2 tabs on VS Code. Layout formatting is customizable to your personal preferences, but we recommend splitting the tabs between left and right sidebar to maximize efficiency. By selecting a function, I'm a quick keyboard shortcut away from a concise summary with dependencies listed below. Further requests can be directed to the assistant, be they for further explanation or recommendations for modifying code. And to integrate with whatever tools you may use, Code Explain's history automatically saves, allowing you to come back later. And this is not just in Python, but Code Explain works in C++, TypeScript, and a whole slew of other languages, as long as VS Code syntax can detect it.